we will be starting in a minute or two. There are some videos I had sent on the WhatsApp group. Did we happen to watch them? Especially the one on probability tree diagrams. No reply. That means we did not. So since there was no reply, let us just go through the probability tree diagrams, and then you read the rest. You'll practice more and more. So we can try doing this number together. Who can read for us? You people, today you are not in the mood of talking.
A bag R contains 3 red balls and 4 black balls. A bag Q contains 3 red balls and 2 white balls. One bag is selected at random, and then from the bag, a ball is picked at random. Find the probability of picking a red ball, a black ball, a ball from R given the red.
Okay, thank you. So we have our 2 bags, which have the different balls in them. So we have a bag R which contains 3 red balls and 4 black balls. Then we have another bag Q which contains 3 red balls and 2 white balls. So we are selecting one bag. So one bag is selected at random, and then from it, a ball is picked. So how are we going to represent that on a tree diagram? So how are we doing this number? Any idea? Okay, so what we are going to do is just to follow instructions. So we are saying, first of all, we are picking a bag. So we are going to begin from by having the 2 arrows. So 2 arrows. So one of the arrows indicates bag. So we can say this is bag R, and then this is bag what? Q. And then we draw our 2 bags and indicate what is in each bag. But before that, what is the probability of picking the R and the probability of picking bag Q?
A half.
A half. Okay, thank you. Any other suggestion which is different from that? Me. Okay, so the probability will be a half. So this will be a half since there are 2, and this one will also be a half. So bag R contains 3 red, bag 3 red and 4 black. Then bag Q contains 3 red and 2 white. So from these bags we are picking once. So we are picking once. So here we are going to pick a red, or we are going to pick a black. So likewise in this downer bag we are going to pick red or black. So what is the probability of picking a red ball from bag R? What is the probability? Yes, Joel. What is the probability? Okay, I think it was a typing error. There's supposed to be two red, three. There's supposed to be red balls and black balls. So that is just a typing error. So this one is also supposed to be black.
Black.
Yes, it was just a typing error here. So this one is supposed to be black. Okay. So the probability, yes.
Teacher, you can go.
So the probability of picking a red ball from bag R will be 3 divided by the total, which is 7. Then picking black from the same bag would be 4 divided by the total, which is 7. Then when we go to bag Q, the probability of picking red would be 3 over total, which is 5. Then this would be 2 divided by 5. Any question before we proceed? Seems there is none. Now we are going to find the probability of picking a red ball. So this is red, this one is also red. So for Roman 1, probability that it is a red ball will be probability of R, bag R, intersection red, okay? Or, which means addition, probability of Q Okay, so sorry about that. So this will be probability of Q intersection R. R to represent a red. So this would be the same as a half. We multiply that by 3/7. And then we add a half for Q, and then still multiply that by 3 divided by 5. So 1 times 3 is 3 over 14. Then we are going to add 3 divided by 10. So those with calculators, you can enter that value first, and then we get an answer.
Eighteen out of 35.
18 divided by 35. Any other? Do we all have the same answer? Okay, so we can have that 18 over 35. Then we go to probability that it is a black ball, so it is still the same procedure. So the black is R intersection black, or probability of Q intersection black. So this would be a half times the black on the first one R is 4 over 7, then plus a half of the black, which is probability of black, which is 2 over 5. So this would be the same as when we reduce this by 1 here, up here is by 2. So it is 2 over 7. We add 1 over 5. And what would be the answer? Two over 7 plus 1 over 5 on a calculator. So by calculator, this would be 17 divided by 35. Is that what we are getting on our calculators?
Yes.
Okay. Had we in our schools studied about conditional probability? If any? You people today are very good at keeping quiet. Okay, so on this probability, So the one of red was the 18/35. The black one was 17/35. Then for conditional probability, it is a condition. So A, like for example, A given B is defined by probability of A intersection B. Then we divide this by probability of B. And this one here is read as probability of A given B. Is abbreviated, is read as probability of A given B. And this is how it is defined. So we get A intersection B, then we divide it by the probability of B. So likewise, we are going to have this statement here in that form. So I'm saying a ball from R, given that it is red. So we are going to have it is as R of bag, given that it is what? It is red. And this one will be equal to probability of bag R intersection red. Then we divide this by probability of getting a red ball, which we had calculated at first. So this is going to be the probability of picking bag R was a half. Then we multiply it by probability of picking red, which we can go back and get, which was 3/7. So that would be 3/7. And then we divide everything by probability of red, which is 18 divided by 35. So this we can rearrange it. So this would be 3/14, the upper one. Then we divide it by 18/35. So since we are dividing fractions, we are going to multiply by the reciprocal. So 3/14 multiplied by 35 divided by 18. So those with calculators, you can help us. Let me do this simple one. By 1 here, here is 6. So 1 times 3, 35. So 35/14 times 6. One times 35 divided by 14 times 6. Which answer do we get? Okay, Joel, 5/12. Okay. Any other? Same answer?
Same answer.
Okay. Even me, that is what I got. So that would be for that question. So we can go to the next. So the next question reads, an urn contains 4 green and 5 white beads. 3 beads are drawn from the urn at random with the replacement. Find the probability that the 3 beads are of the same color, then 2 of the beads are of the same color. How many of us watched the video I sent on the group? By show of hand. None. None did. Okay, so here we are going to have so we can still have them in like box form. So we have 4 green and 5 white. So we are going to pick 3 times. So we can give it a boundary. Of the 3 times we are going to pick. So the first time we shall pick either a green or a white. So what will be the probability of picking green here? What will be the probability of picking green?
4 out of 9.
Out of 9. And then this would automatically be 5 out of 9. So here we are picking again. And still here. So here still we can pick green or white, green or white. So this would be for the second time. This is the first, this is the second, and then we shall have the third. So on this third, we still have 2 options on each, picking either green or white, green or white, green or white, then green or white. And then after that, I said it is better for us to pick, to give a summary at the end of each branch, if we call them branches, like our tree is supposed to have. So this would be G1 intersection G2 intersection G3. So we can do that for the rest. So G1 intersection G2 intersection W3. Then here we can still have G1 intersection W2 intersection green 3. Then G1 intersection W2 intersection W3. Then now we begin with the white 1 intersection green 1 intersection green 2. Then we have W1 intersection G1 G2 intersection W3. Then white 1, white 2, and then green 3. White 1, white 2, and then white 3. So now where do we have all the 3 beads? being of the same color. So where do we have all the beads being of the same color?
Green 1 intersection green 2 intersection green 3, and white 1 intersection white 2 intersection white 3.
Okay. In probability, it is better for us to say all. So green 1, green 2, green 3, because when you say inter and means intersection, so you'd have introduced another concept. So where we have beads being of the same color, so we have probability that they are of the same color. The probability of green 1 intersection green 2 intersection green 3, all, which means addition, probability white 1 white 2 white 3. Then here we'll just multiply. Remember, our probability is with the replacement. So with the replacement, our beads do not reduce, and that means the probability remains the same. So 4/9 times 4/9 times 4/9. Then we shall add 5/9 times 5/9 times 5/9. So this would be equal to 4 times 4 times 4. What is 4 times 4 times 4?
8.
Yes?
8.
8. Thank you for trying.
4 plus 4 is 8.
Times 4 times 4 times 4. Multiplication, not addition.
Oh,
Yes. So the answers are in the chat. Okay, Himsiwe has given us the final answer, I think, as 22/7. What is 9 times 9 times 9? 7 to 9. Is it the answer? Let me also try on my simple calculator here. 7/27, final answer. What do others have to say? Is it the same answer that you have as well? Times 3 has 7/27. I also have that. Any other one who has the same answer? Yes, Karen. I don't know whether that is the right pronunciation.
Teacher, what if I don't do the working? Like that second, or down on the second line, that one.
This
If I
one
don't,
here.
yes, will I get all the marks?
Yes, in paper 2 you do.
Okay.
You'll get the marks as long as you have the final answer. Only that some of it I'm just doing it because it is classwork, okay?
Okay.
But after you have drawn your tree diagram, you have stated this probability that the beads of the same color is equal to this G1 intersection G2 intersection G3 plus, then you have substituted here. So they know you have a scientific calculator, so you can enter all these values at once, and then it gives you 7 out of 20 out of 27.
Okay.
Yes, because that one will help you to save on time, because the challenge with paper 2 is always time and your calculator. So once you are able to manage those two, then you'll be able to do a lot in paper 2. And the only way to manage time is to reduce on the number of unnecessary steps. There are ones which are necessary, and then there are others which are unnecessary. Is that okay?
Yes.
Okay, so we go to part B. So part B, what could be the shortcut if we are in the exam? Let us do the brainstorming. Writing well, yes. Sometimes you find that you can't change the handwriting, and you have, as long as your digits and what you are writing is visible, I think that is enough to me, because not all of us can afford to write very well. The handwriting, you need to just practice. The more you do the numbers, you get used to them, is the more you'll be okay. It's the practice will help you to better go through the numbers, but it doesn't have so much to do with the handwriting. So it will just help you to do the numbers faster. No, Joel, the writing, when you write well, you are caught up by time. Is that true? So you have to write badly so that you finish in time. That is very interesting. So how do we do the part B while saving time? While saving time, what are we going to do? Please suggest. The diagram is there, so you can suggest what we can do. Emily, you have been silent, say something. And Arvin.
Master, may I answer the question?
You can answer again. Emily?
Yes, teacher.
Say something on this number. On part B probability that the beads have, two of the beads are of the same color.
I think we are going to go back to our tree diagram and then pick the set where we have two colors that are the same. Maybe green and green, then white and white with another color.
Okay.
Mm.
So for example, here where we have green 1, green 2, so those are already two colors. Okay.
Yes. And
so
white.
we shall take that. Then we have white and white. Okay, green. Let me see. Yes, green 1 and green 3. So we shall as well take this.
And the next.
So this one is white and white. Okay. Green and green. White and white. So there are two. White and white. They are still what? 2. So we notice that all these ones here contain what? Have 2 of the beads being of the same color. Okay. And we know that total probability is equal to
1 whole.
1 whole. So when we get the probability of all of the balls having the 3 colors, okay, because that one we already have it, plus the probability of 2 of the beads having the same colors, which we have seen are all these ones, that should give us a what? A 1. Is that okay? Or I should repeat? I am saying a yes. I don't know whether it is for repeating or whether it is for okay. Okay, let me just simply repeat. So we calculated the probability of getting all the beads having the same colors. Okay, and that was green, 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 and white, white, white. Now we are noticing that apart from the green, 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 and the white, 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 these other ones that have remained have 2 of the beads being of the same color, as I have indicated here. So all these ones have the same what? The same color. So when we add all these probabilities here, they should be able to give us a what? A 1. But we have already calculated the probability of white, 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 and green, 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 and got it as 7/27. So when we get the probability of white, white, white plus green, 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 plus the probability of all these ones, we equate it to 1 because that is the raw total probability. So it should be able to give us a what? A 1. So I'm simply saying that when we get probability of the beads being of 3 beads same color. Okay, let me write just the 3 beads being of the same color plus probability of 2 of the beads having the same color. That should be able to give us a what? The 1, which is total probability. So this one gave us 7 out of 27. So we shall add this. And we equate it to 1. So the probability of 2 beads would be 1 minus 27. No, 1 minus 7 over 27. 1 minus 7 over 27. And that would give us, what is that value when we use a calculator? Or our head, because our head can as well give us that answer. Okay, it says 20 over 27. I have to 20 out of 27. Okay, so our answer would be 20 divided by 27. So this method here would be a shortcut to help us save on the what? On the time. However, if the worst comes to its worst, you can go back, okay? We can go back and get this probability plus this, plus this, plus this, plus this, plus this, as we have done here. But still you'd end up with the same probability, which is 20 out of 27. Is that clear? You have done it and it has given you the same answer.
Yeah. It's the same.
Okay.
Let's see.
Any questions before? Okay, for shortcuts, it is okay, but finishing, I told you one of the major problems in paper 2 is time. So you might know your information, but time becomes what? A problem. So the best way to do that is to do enough practice. Is to do enough what? Enough practice. Yes, that is when you'll be able to finish in time. Otherwise, if you don't practice, then you reach in the paper and you are not flowing. So the answers are not flowing as you expect them. So you tend to now first pause, then think of what to write. So time would be moving, okay? So you need to somehow devise. So as you work, as you do practice, that enables you to do what? To become confident, to devise means of how you can do things better and faster. So that is the best, but even the shortcuts need time to do them. Okay. Like now we have taken almost the whole hour doing 2 numbers. Okay, so I think because of time, we are going to stop here. But please feel free, if you have a question, you can contact me. If you have anything to consult, you can contact me, and then we arrange and meet. Then yesterday we were supposed to have a lesson of paper 1, but I didn't make it. I hope you have forgiven me before God. So I am going to sit down and record that lesson and send it on the group. Otherwise, nice day to us who have not taken lunch. Nice lunch. We meet. But none of you has done the assignments. You are not good at doing assignments. The recording, what is the problem with it? If we are being recorded while talking. Joel, if we are being recorded. Okay, we can end the meeting because this same Zoom chain is going to be used for another lesson at 2. So we can leave and we do I'm going to send some little work for you to do. So please do. And after send the work for what? For marking. So thank you for attending, and goodbye for now.